All right, cool. Well, let's get started. Hi, we're here to talk about holistic quality engineering. How do you engineer quality into the way that you write software? Forgive me if I cough or sniffle into the mic. It's that time of year where I'm allergic to the air. So I'm sorry, I'll do my best. I've got my tea over here, so I'm going to pause and sip on some tea to hopefully keep that to a minimum. A couple of public service announcements before I really get into the meat of the talk. The first one being please wash your hands, wear your mask, do the social distancing thing. Please help stop the spread of the Rona. And also, there's a lot going on in politics right now, and your voice matters. So please vote. Dang it. It's important that you do. All right. So it's fair for you to ask the question, why should I listen to this guy that's talking right now? Hi, my name's Floyd, and I'm the owner and principal consultant of Canyon Trail. And Canyon Trail is a company I founded last year to help organizations learn how to do software better. I've been writing software professionally for a couple of decades. 2021 will be the start of the third decade in the software industry for me. I started in QA doing software testing, so I know what it's like to be that person who everybody is like tapping their foot and waiting on, like, oh, come on, Floyd, are you done testing yet? Is that really a bug? Do we really have to hold off and not ship because of this little fiddly thing that you found? So I know what it's like to be doing quality work and be the person that's sort of the gatekeeper of whether or not things are okay. And also to be the one that's on the receiving end of the blame. Oh, how did we let this bug get out? I've been leading teams for about 7 years from like dev lead or all the way up to director of technology. So I know a little bit about leading technology and software organizations. And also, there have been a couple of companies in my career history that I've saved from quality problems that were threatening their very existence. If these companies didn't have me helping them figure out how to deal with their quality problems, it was threatening like losing clients, potentially them having to shut their doors. So I know a little bit about software quality. What we're going to be covering today, we're going to talk about how do we define quality, measure it, how do we improve it. What we're not going to be talking about today is the product management side of that. So we're not going to be talking about requirements or story refinement or anything like that. If you've got schizophrenic product vision, this is not the talk that's going to help you. Not that I don't want to talk about that. We just only have so much time. So let's talk about quality from the perspective of we've got a wide variety of people that are here. You all work in different organizations. You build different kinds of software. When I think about quality and I think about quality standards, I think about organizations to look at to ask questions about, okay, who's doing quality really, really well? I think about companies like Netflix and Spotify who have worldwide availability considerations. They've got 24 by 7 availability considerations. They've got millions of users. So if they do it wrong, there's going to be a lot of unhappy people. I think of those kind of on the high side of quality. Now, on the low side, you've got the software development equivalent of Jim Bob's handyman service who cobbles it together with duct tape and baling wire and hopes to collect a check before it all falls apart. My guess is that most of us are going to fall somewhere in the middle of this spectrum. We don't want to be over here, duct taping things together, but we also don't want to be over there on the far right necessarily because maybe we don't have 24 by 7 availability constraints. Maybe it's okay if we have a little bit of downtime at midnight because everybody's at home asleep. So, what that means, really, just from a big picture perspective, is that quality is going to mean different things to different organizations. Some of the quality constraints that are true of one organization or one piece of software are going to be different for another one. Now, with that, we've got to talk about the perception of quality and what does quality mean usually, and what are the things that are lies about quality that will cause companies to make really bad mistakes. So this graph here, for instance, this is a lie. It's a lie to believe that there's a linear trade-off between quality and speed, meaning if I go faster, that means quality is going to go get worse, and if I go slower, that's going to improve quality. See, a lot of organizations they're going to have a line, and they're going to say we can't let quality get below this, and this is their standard of quality. What that often means is that companies will perceive this area right here as the zone of waste, meaning we want to go as fast as possible to get as close to this line as possible. but we don't want to go any faster because it means our quality is going to drop. Now, bear in mind, this graph is a lie. I'm explaining the lie that many companies believe. So what I'm telling you is this is the weird falsehood that a lot of companies sort of make up in their brains. So the idea here being investing anything in quality means that means we're going to be slowing down. Therefore, investing in quality to take us away from this line is just waste. We're just wasting dollars, we're wasting time, we're wasting money. So if you're not a visual person, maybe you're a text person, you might hear phrases at companies like this, like improving quality means slowing down. This is a falsehood. Our quality is good enough. Why waste money on improving it? This is a falsehood. What's probably more true is something a little bit more like this. Where you've got poor quality practices, you may have possibly something that maybe kind of sort of looks like a linear trade off. But as you improve your quality practices, what you wind up discovering is that better quality also means better speed. As you get farther and farther out here, notice the colors, the color gradient here. Not only are we improving quality, but we're also going faster and faster. Quality enables speed. This is why we should care about quality, because ultimately, at the end of the day, what quality is an efficiency measure. How effective are we at taking the investment of software development, um, time and money? How well are we spending software developer salaries on delivering value? And if the delivery of that value is all tangled up in rework and fixing bugs and really, really slow code review processes or really tangled up software architecture that takes forever to change, well, that's not very efficient. So, what's also true is that there's time dynamics involved. So, if you look at the left side of this graph as the beginning of a project, and then the right side is as projects mature over time, what you'll discover this is, by the way, the design stamina hypothesis by Martin Fowler. What you'll discover is that if you invest in quality early, you may get a little bit of a slower start, but that pays off as this red line curves upwards. Whereas if you neglect quality, you may get a quick start, but over time, what winds up happening in this yellow line, you wind up going slower and slower, where it costs a lot of time and it costs a lot of money and it costs a lot of headache to deliver the same little bit of value that was a little bit easier a couple of weeks ago or a couple of months ago. If you invest in quality, what you wind up getting is acceleration. It actually goes faster over time if you invest continually in improving quality. Now, for the rest of this talk, we're going to play out a scenario. And this scenario is you are all now my employees here at Floyd Co Soft. I'm the CEO, and I've made some decisions because we've been having some quality problems. One of those decisions is I just fired the entire QA department because they weren't getting it done. That means also we're not hiring anybody else with quality in their title. And for me as the CEO, the reason I'm doing that and the reason I'm going to take you all through this scenario with me is because of this. Quality is everybody's job. Here at Floyd CoSoft, we're all responsible for quality. Well, what does that mean? Well, we've got a couple of different kinds of quality we got to think about. And these are two broad categorizations of quality, internal and external quality. So, external quality over here on the left, these are the kinds of things that you can observe directly as an end user. So if there's a bug, you can see that as an end user. If the software has the feature that you're looking for, you can see that as an end user. The UI, the UX, even the performance. These are things you can directly observe as an end user. Whereas internal quality, you can't very easily or very directly observe it and measure it. These are your illities like testability, maintainability, observability. This is software architecture, coding standards, delivery metrics, things that you can't really see as an end user, but these are quality measures just as much as external quality measures. Excuse me. Now, one of the reasons why I fired the QA department is because there's this relationship between testing and QA. And a lot of times what winds up happening with this relationship between testing and QA is that they're closely related. So closely related, in fact, that sometimes organizations will just bridge this gap and say, okay, testing is done by QA and QA are the testing people. This is a fundamentally broken way of thinking about the world, and it will cause you quality problems. So, why wasn't our QA department going beyond testing? Well, reason the first, they were too focused on external quality. They were so focused on what you could observe as an end user that they didn't take advantage of the fact that there are things that you can measure from a quality perspective that don't have anything to do with testing, that don't have anything to do with anything that you can observe directly as an end user. And a lot of times, these quality measures are more effective at preventing bugs than testing. The second reason is that they were unwilling to enforce quality measures. They let the internal politics of pressure to ship let them say, okay, well, we'll go ahead and release it to the world, even though there's bugs. And well, if you've got an angry customer because they're waiting on software and you ship them buggy software, it's not going to make them happier. And the third reason why our QA department, who is now unemployed, didn't go beyond testing is because they were just too busy spending time doing testing. So moving forward here at Floyd CoSoft, I'm going to hold everyone responsible for quality engineering. And there are three facets of quality engineering that I'm going to expect everyone to be involved in. The first one is we're going to measure quality. We're going to have a clear understanding of where are we from a quality perspective. The second thing is we're going to enforce standards. We're going to say, here is our standard of quality, and here's what we're going to do if we don't meet that standard. And then the third thing that we're going to do is we're going to revisit and refine our methods for measuring and enforcing standards. So let's talk about measuring. There are some things that we can do to measure quality. First, obviously, we can do some testing. And we can't talk about quality without talking about testing. I think that's pretty clear. We can measure some technical metrics. We can also measure some business metrics, but like I said a little while ago, this is kind of out of scope for this talk because it's a big topic and we just don't have enough time. So let's talk about manual testing. Um, Over reliance on manual testing is really just stupid and wasteful. So if you know me, if you don't know me, I'll just tell you this about me right now. If ever I say testing, I mean automated testing, unless I say manual testing. So whenever you hear me say test or testing, assume automated. Now, given that, not all automated tests are created equal. And so it's wise to invest lots of different kinds of tests into how you do your testing. Now, for those of you that participated in the survey that I sent out on the Techlahoma Slack org, thank you. Here is some of your data. Now, for the people that participated, thank you again. Looks like we've got about 3/4 of us that are doing unit testing, a little over half doing integration tests, 13.6%, so not very many doing end-to-end testing through the UI. Um, a fair bit of us, a little over a third, doing manual testing from a script. Most of us are doing manual exploratory testing. Cool. I don't know what this product manager tests two thing is. And there are a few of you that are not testing at all. You're just slinging some code and throwing it out into the world and hoping nothing breaks. Good luck. We're all counting on you. Not really. So when we talk about the different kinds of testing that we can do, we've really got to talk about the testing pyramid. And so Martin Fowler is kind of the go-to for the test pyramid. Now, if you go look up the Martin Fowler article about the test pyramid from somewhere around like 2003, you get this visual. And it's kind of an unfortunate visual because it steers a lot of people wrong. Not to say that his concept is wrong, it's just people have a bad habit of looking at the graphics without reading the text. And I've ran into this over and over again where people look at this visual and they say, okay, this means we have three kinds of tests, and three kinds of tests are what comprise the testing pyramid, and that is how we do things. That's really just not what the idea is. So, briefly, let's talk about the testing pyramid. The testing pyramid is a spectrum. And it's a spectrum because at the bottom, we have tests that have certain properties. And at the top, we have tests that have certain properties. And they graduate from one to the other. So, for instance, at the bottom, we have unit tests that are small and fine grained. At the top, we have UI instrumentation and even manual testing through the UI, which are going to be coarse grained and slow. And we're going to talk a little bit more about the testing pyramid and how this spectrum plays out and how it helps you identify various kinds of testing that's going to be important for you to manage and engineer quality into your software. So, the assumption of Martin Fowler's test pyramid is that your application architecture looks kind of like this, where you've got a UI that's somewhat smaller than your backend, probably significantly smaller than your backend. The UI communicates to the backend through a service API, and then there's some sort of data store. So your unit tests should cover both the UI and the backend. You have service level tests, which were that sort of middle area of Fowler's test pyramid. And so that's where you instrument the service API in an automated fashion without worrying about the UI. And then at the top, you instrument the UI and exercise the entire system all the way through. Excuse me. Now, your test pyramid, again, your organization is different. Your standards of quality are going to be different. Your users, your market, all different. Your test pyramid probably won't have 3 layers. That's okay. First off, there are more than 3 kinds of tests. You may have, functional tests, you may have behavior-driven tests, you may have performance tests. There are all kinds of tests that you can do. So, knowing that you have lots of tests, it's important to understand where do they fit in the pyramid, because that pyramid is what helps us understand how much testing of each kind we probably should be doing. And also, you may not need the same kinds of tests as other organizations. If you've got a little bitty to do app, it's probably not important right now to have really comprehensive performance tests, for instance. So let's talk about the dynamics of the testing pyramid and see if we can't, learn, okay, how do I perceive the various kinds of testing that we do? So, for instance, first and foremost, the pyramid organizes different kinds of tests as a pyramid because at the bottom we want lots and lots of tests, and at the top we don't really want a whole lot. So at the top is where manual testing happens. We don't want to rely heavily on manual testing. Cost. So at the bottom of the test pyramid where we're doing unit testing, unit tests are cheap. You can write them quickly, you can execute them quickly, so they're not very expensive. If you have to do some refactoring and you've got to throw away some of those tests, it's no big deal. At the top of the testing pyramid, this is where tests are expensive. Instrumenting a UI and doing all of the data setup and doing all the assertions afterwards, this can be really complex. And so at the top of the test pyramid, it's expensive to write and to maintain um, those kinds of tests. Execution speed. So unit tests down here at the bottom of the test pyramid, those execute very, very fast. They should be executing like 10, 20 milliseconds, maybe even faster. It shouldn't be unreasonable for you to be able to execute thousands of unit tests inside of a tight TDD cycle. Whereas at the top of the test pyramid, if you're doing UI instrumentation, each individual test could take seconds or maybe even minutes, depending on what kind of stuff you're doing. So execution speed, fewer tests at the top where those execute slower, lots and lots of tests at the bottom where those execute quickly. Let's talk about coverage. Now, this one's fun because there are 2 facets to it. Unit tests, they should be covering, each individual test should be covering a very narrow area of your code. Whereas near the top of the test pyramid, so if you're instrumenting your UI, driving your UI from an automated fashion, that's going to execute a whole lot of code throughout your system. So you get more broad coverage up at the top of the test pyramid than you do at the bottom. And that sounds good, but there's another facet to that. And that is you get better failure locality at the bottom of the test pyramid. So if you have a test at the top of the pyramid, so like say your UI instrumentation and it breaks, you've got a pretty significant debugging effort to try to figure out, okay, this test broke. Why did it break? What's going wrong? Versus a unit test near the bottom of the pyramid, you've got a very small area of the code that you've got to look through to figure out what's broken. And for me, as the CEO of Floyd CoSoft, there's value in both. Like it's important to me that you can debug quickly because that means bugs get fixed faster. But it's also important to me at the top of the test pyramid to have some automated tests to know, is the system put together properly? Overall, is it working as expected? This gets into fragility as well. Tests near the top of the pyramid are more fragile, meaning that they are likely to break for reasons other than the code is wrong. So, again, top of the test pyramid, those kinds of tests tend to be fragile. So if you're instrumenting a UI, for instance, and you do some redesigning in the UI, so just visual redesigning, some of your UI instrumentation tests may be susceptible to breakage because you're just moving pixels around. Hopefully not, Depends on how you're doing your UI instrumentation, but that is a possibility. Whereas down at the bottom of the test pyramid, where you've got unit tests, functional tests, integration tests, those should be more stable. Those should be more robust. Those should be more resistant to not breaking for reasons that they shouldn't break. Now, real world alignment. So when we think about UI instrumentation at the very top and the various sort of graduations down to the bottom, if you're driving the UI similarly to how a user would do it, well, then that means you're sort of aligned to real world scenarios. Whereas down at the bottom, where you're dealing with fine grained little bits of logic, that's really not quite as connected to what an end user does. So some various perspectives as you think about what kinds of testing can I do, what kinds of testing should we do, and how does that align to sort of real world usage? Let's also talk about manual effort. We said a little while ago, manual testing is kind of wasteful and it's bad. We don't want to over rely on it. So at the bottom of the test pyramid, it should be really, really easy for the computer to do all of the work. At the top, we might have a few manual steps to set up for doing a test run. That's okay. And what we want to make sure that we're doing is if there's manual effort involved, that probably means it belongs near the top of the test pyramid. And it probably also means that we need to try to pull as much of that logic down and test it near the bottom of the pyramid where it's a little cheaper. So, finishing up talking about the test pyramid, whatever kinds of tests that you're doing, know where they live in the pyramid, have an understanding of where does it rate? Are the tests easy to write, easy to read? Okay, that probably means they need to go down. Are they cheap? Is anybody going to be brokenhearted if the investment that I made in this test goes away because we've got to do some refactoring? Okay, that helps. Invest your testing effort accordingly. Don't make a test ice cream cone. And what do I mean by that? What I mean is don't spend all of your effort doing testing in slow, brittle, error-prone ways. Instead, you want to invest your testing effort where the bulk of your tests are cheap and run fast, and then fewer and fewer of your tests go up the pyramid where they run slow, where they're expensive, and where it's hard to maintain them. So other than testing, let's talk about technical metrics. So what are some technical metrics that we might want to care about from a quality perspective? Well, we might want to know how big the code base is and how fast it's growing. It's not good or bad, but it is an important and worthwhile metric to understand. We might want to know what our test coverage is. We might want to know what we're how well we're performing. So we might want to keep some performance benchmarks around. We might want to know what our lead time is. So how long does it take a customer request to turn into working software in production? We might want to know what our cycle time is. That is, when the code gets committed, how long does it take for that to commit to get to production? We might want to know what our defect rate is. How often are we shipping broken code? Mean time to recovery. When we do ship broken code, how long does it take us to fix it? There are lots and lots of different kinds of technical metrics that we could be tracking as a part of measuring our software for quality. Now, some of these we had in the survey. So, cycle time. How long does it take once the code is committed and we mark it done in the issue tracker? How long does it take to get to production? Looks like over half of us. Am I? Nope. I'm reading that incorrectly. So, it looks like about a third of us are able to ship that in less than a day. Less than a week gets us up to the halfway point, up to a month. So some of us, so we're looking at roughly about a week is sort of half of us. How much time are you spending improving quality? This is an interesting breakdown. So there's a fair bit of us that are investing 10% ish, maybe, or between 5 and 10%. This is nice. So these are some technical metrics that we could be tracking. Change failure rate. So how often are we shipping something that's broken? Looks like we've got some cool quality standards here. We've got 40% of us that are shipping breakage less than 5% of the time, and that's pretty awesome. It's pretty awesome that you're that high of quality. I would ask the question, how are you measuring that, and are you sure, or are these just the ones that you found? And then there's also a fair number of people here that don't know what their change failure rate is. And so again, this is quality. This is how do we know what the quality is? Well, you got to measure. Typical recovery time. So this is how long does it take when we've shipped something broken? How long does it take to get it unbroken? How long does it take to fix it? So about 2/3 of us are fixing that in less than a day, which is pretty good. Less than a week or longer, and again, no way of knowing. All right, so that's measuring quality. So let's talk about enforcing standards. In order to enforce standards, you must have standards. Sorry, terrible joke. So how do we enforce standards? Well, there are a few different ways of enforcing standards that we could put in place. One of them is a gate. Excuse me. A gate is a stop in your process that says we cannot ship this because it doesn't meet our standards of quality. So this should be test failures. We can't ship this until we meet this standard. We can't ship this because some of our tests are breaking. Another kind of standards enforcement thing that you can do is remediation. So maybe it's too slow or maybe it's too expensive to hold up the show for the purpose of measuring something, or maybe it's really, really hard to measure it outside of production. So we get it to production, we discover, oh, we're not meeting our SLOs. Our performance is dropped significantly. We're going to have to do remediation, which means based on our rules, we might not work on any new features until we get this thing fixed. And so this is a decision that you have to make for your organization. And then another one, and I'm calling this an exception. So this is a really valuable thing in doing standards enforcement. So let's say we've got a web API and we've got 200 HTTP endpoints in that web API, and all of them but one perform reasonably well. They finish in less than 300 milliseconds. But we've got this one endpoint that's dog slow because it's calling a bunch of stored procedures, and there's a hamster wheel involved in there somehow. I'm just not sure, but for terrible reasons, we can't change that yet. Um, it's a whole lot better to say, you know what, we're going to tighten the constraints on quality for 199 endpoints. And we're going to say, if they get beyond 400, 500 milliseconds, we want to know about it. And then for this one over here, it's special, and we're going to make a special rule for it. And I've got a caution symbol here because you can easily let this get out of hand. But actually, what I mean by this, it's really not making exceptions, it's making fine-grained standards. Meaning the standards for one area of your software may be different than another area of your software. And the way that you enforce may be different for one area than another area. And that's okay, and that's healthy, and it's good. So, if we're measuring our software and we're enforcing standards of quality, that is our quality strategy. But that's only the quality strategy for right now. So that takes us back to this three broad areas that I, as the CEO of Floyd CoSoft, am going to be holding you accountable for as my employees. And this is the third one: refining our methods. If you're familiar with the parable of the blind men and the elephant, you might recognize this picture. And if not, well, long story short, a group of blind men were trying to figure out, well, what is an elephant? I've never heard of one before. So let's go find an elephant and let's see what we can learn about it. And one of them feels the side of the elephant and it's like, oh, it's like a wall. Another one that feels the trunk and it's like, oh, it's kind of like a snake. I don't want to talk about this guy at the far right here. You. Um, the reason I bring this up is because quality is really hard to measure. You can't just put a set of calipers on quality and know exactly like what number is quality. Quality is at 73%, sir. No, doesn't work that way. So we're always measuring quality by proxy measures. We're measuring something that is an indicator of quality, but because we can't directly measure it. And sometimes we get it wrong. All of the blind men were right. Yeah, parts of an elephant are like a snake, parts of it are like a tree, parts of it are like a wall. But that doesn't really tell you what an elephant is. Also, sometimes we make mistakes in how we measure quality, and we need to learn a better way. Also, sometimes we make decisions in how we measure and enforce quality that might be holding us back. Some quality practices might be training wheels, and we might need to revisit them over time so that we can grow and go faster. So that means we've got to frequently revisit our measures and our enforcement. So, quick recap all that we've talked about thus far. Quality enables speed. You can't go faster if you're not sure if the wheels will stay on. Quality is everybody's job. Nobody gets to say it's not my fault when we ship something broken. We've got to work together. If you're working for me at Floyd Soft, which is, of course, a fictional company, I'm going to hold you accountable to these three areas of quality engineering. So now you may be going, yeah, Floyd, that's great, but we're not doing much of that at my organization. Where do I start? So I'm going to give you, as a bonus, Floyd's fabulous three-step plan to better quality. Step one, we're going to do some continuous integration. We got to have unit tests. We've got to have a CI build that runs on check-in, and it needs to break if the unit tests don't pass. And then we've got to fix the build because we're going to start using the output from that build as whatever goes down and eventually gets shipped. So instead of building from a developer's workstation, we're going to build and we're going to take the build artifacts from that CI/CD system, and we're going to move that along in our process flow. Step two of Floyd's fabulous three-step plan to better quality is we're going to do this frequent inspection and adaptation loop. So we're going to make some observations about the world. We're going to analyze those observations, try to figure out what does this mean. Based on that analysis, we're going to make a plan. We're going to put the plan in place, and then we're going to start all over again. So let's pick that apart a little bit. So step one, we want to make some observations. So we're looking for things like slowdowns. What's taking a long time that we feel like could be going faster? Where are problems happening? Are we having bugs? Are we having deployment issues? Are we having angry customers? And where are our headaches? Where are our morale problems? What are the things that are just sucking the joy out of writing software? Um, and step two, we want to analyze this. So we've made some observations. We see things going on. We want to look for patterns. We want to look for root causes, not just one. I say causes because a lot of times people say, "Well, why is this happening?" And they don't keep asking why. So there's this thing called the discipline of 5 whys. So when you're doing analysis of something, we want to ask why a bunch of times. So for instance, um, we have a critical bug that made a high profile customer angry. Well, how did it get to production? Well, we didn't write enough automated tests for it. Why? Well, because we had pressure to ship. Why? Because we don't have standards of quality to say, well, we can't ship because we're not meeting our standards of quality. Well, why not? Because nobody thinks it's important to have a standard of quality. Oh, okay. So maybe asking why a few times helps us get to the bottom of what's going on. Um, Once you've analyzed your data and you've figured out, okay, here's this problem we want to try to address, you got to make a plan. And I like Mad Libs type things. I like the Mad Lib style of user story refinement, and I like the Mad Lib style of how do we do quality improvement. I think if we put this change in place, it will improve something that actually matters, and we'll use this measure or this metric to see if we're right. And I like doing it this way because there are three important elements. Number one, we got to know what we're changing. Number two, we've got to be able to articulate this as something that actually matters to the business. Because if it doesn't matter, you're not going to get buy in. And then number three is you've got to be able to measure to see if this is working. Sometimes those measures are going to be easy. They're going to be hard numbers that you can measure. Sometimes they're going to be qualitative. Sometimes you're going to have to try it for a while and just sort of get a general vibe like, hey guys, is this working better? Forgive me. Hey people, or hey folks. Sorry, I'm trying to fix myself not using gendered language. Step three, once we've made a plan, we got to do the thing. We've got to actually put the plan in place. And then we've got to start the cycle all over again, right? So sometimes making that plan might be let's bolt on some training wheels so we don't fall over as much. All right, great. Now we're not falling over as much. Let's take the training wheels off and see if we don't fall over anymore. Hey, look, we're not falling over and we're going faster. Awesome. Now, Floyd's three-step plan to better quality, there's a third step. And this is the secret. This is the thing that really ties it all together. There is no step three. What? Yeah, there's no step three. Three-step plan is set up some continuous integration, start an inspect and adapt loop. There is no step three. Are you sure, Floyd? Yeah, yeah, I'm sure. Here's why. Because really, Floyd's fabulous three-step plan is actually a one-step plan, but that usually doesn't work. Step one is you've got to do something small that buys you some credibility. You've got to sell the idea to your organization that, hey, we did this thing and it's improving quality like this. And this quality improvement that we got is actually something that matters. We did this unit testing thing and check it out. We have fewer bugs going out. Check it out. The build and deploy process isn't painful and people don't have to be here until midnight anymore. Then you can use that credibility to put this inspect and adapt loop in place and actually have some real organizational change. So, if you need some fodder for getting involved in this continuous quality improvement process at your organization, sometimes it's useful to know what's possible. These are the big four DevOps metrics. They're called the big four because they're great sort of trailing indicators for how are we performing as an organization. So lead time, this is based on the book that this comes from, how long does it take to implement and get it into production? So coding, testing, everything that it takes to get to production. We're not talking about like the requirements process. They call that sort of the fuzzy front end. That's not encompassed in this. So deployment frequency. How often are we deploying to production? Not to staging or QA or UAT, but to production. Change failure rate. How frequently are we shipping something that's broken? And then mean time to recovery, we talked about this earlier. How long does it take us on average to fix something that's broken? So, high performing organizations have lead times under an hour. They deploy on demand multiple times a day. They have change failure rates somewhere in a range of about 0 to 15%. And their mean time to recovery is less than an hour. So, if your organization doesn't measure up, this isn't like, oh, you guys suck. This is to say, well, we can't possibly deploy multiple times per day. Well, why not? Well, because testing takes 2 hours. Why? Because we're over relying on on manual testing. Oh, okay. So if we had more automation, we could deploy more frequently, right? Yeah. Okay. Let's try that. If you want to learn a little bit more about software development quality, I recommend these two books. The first one here on the left, this is The Nature of Software Development by Ron Jeffries. It's a great book. It's also a great primer for software development if you're not a programmer. So if you need something to share with your managers, or if you're just not a programmer and you just kind of want to get a sense for how is this supposed to work, it's a great book. The book on the right, that's where these big four DevOps metrics come from. This is Accelerate by Dr. Nicole Forsgren, Jez Humble, and Gene Kim. This is a fantastic book. It's the culmination of a multi-year research project. So not only is this the analysis of this is how to do software well, but it's also research backed. So you're not just getting somebody's opinion, you're also getting here's what the data says about organizations that do well and organizations that don't. Also, I'm on the Techlahoma Slack organization. If you have questions about how to improve quality, I'd love to talk to you. We're going to have some Q&A here in a couple of minutes. Also, a little bit of shameless promotion. Um, this is kind of my jam. It's what I do for a living. So if your organization is looking to hire somebody to help you figure this out, get a hold of me. Before we turn it over for Q&A, I want to give a quick shout out to Kimberly Collins. I'm not going to call you Kim. I learned better. Oops. Kimberly was the one that got me involved in doing this talk, so thank you so much. And then, without further ado, well, this was too awesome. You don't have any questions.
It was pretty awesome. Thank you. It looks like we have a question from Fletch. As a hypothetical Selenium dev or perhaps a C Sharp dev, how do I know what test to write?
Great question. So, first question is, are you writing unit tests? And if the answer to that question is no, go no further, because unit tests are the foundation of the test pyramid. Those are the easiest way to introduce quality into your software development process. If you're not writing unit tests, there's probably a very good chance that your test pyramid is all wrong and that you're over relying on manual testing when you can leverage the computer to do a lot more of your testing. And computers are cheaper and they're faster and they don't get bored or frustrated or don't slow down or make mistakes because they didn't get enough sleep last night. Humans, on the other hand, are susceptible to all those problems. So computers are cheaper and they do the tedious stuff like testing a whole lot better. Let's use the computers for that stuff.
Okay, but on unit tests, like how do we know which ones to write?
If you have code that you're shipping to production that end users use, cover it with tests.
So your goal would be 100% coverage with unit tests, or are there some unit tests you would not write?
Ooh. So that's fun. No, the goal is not 100% test coverage, and 100% test coverage with unit tests is also a really terrible goal to chase. Really, what you want to do is you want to make sure that you're doing test driven development. And the reason I say you should be doing test driven development is because test driven development is the combination of both the technical practices and the psychology of making sure that you're not lying to yourself about whether or not you've got a reasonable amount of coverage on your logic. If you write your code and then you write your tests afterwards, you're going to be in a position where you're probably going to be lying to yourself about whether or not the code is doing what you think it's doing. Also, if you write your code first and then you write your tests afterward, you often find yourself in the position of, well, I wrote the code and I think the code works, and I'm pretty sure the code works based on my manual testing, but now I don't know how to write automated tests for it. Well, TDD forces you to write your code testable, and testability is one of those illities that is an indicator of quality.
All right, great questions, great answers. We don't have any more questions yet. I'll give it a couple of minutes and I'll go ahead and turn my camera on so you can see that I'm a real person here. We will be opening the call to everyone to come on and chat off the stream and ask Floyd any questions or just chit chat with us. I'm going to give it just another minute or two to see whether anyone types up a question because I know that can take a second to do. And Fletch has another question. What is one way of measuring change failure rate?
What is one way of measuring change failure rate? Bugs found by customers in production. Another one might be based on performance objectives. So, for instance, if you've got performance SLOs or SLAs and you discover that now we're out of compliance with this SLO or SLA. So, for instance, one of the examples that I'd mentioned earlier, let's say your HTTP endpoints need to respond within 300 milliseconds, and we just did a production deploy, and now we've got this one endpoint or seven endpoints that are now taking 500, 600, 700 milliseconds. That's a change failure. And what we want to measure is how many times do we have change failures like that? How many times do we ship bugs or how many times do we ship code that doesn't measure up to our performance standards?
And Fletch, if you want to go ahead and join the call now and keep chatting, keep answering questions, you can do that, or keep everybody can keep posting them in Slack and on Twitch. I think I will go ahead and post the link. And so anyone who wants to come on and chat with us, feel free to go ahead and do that. I want to say thanks again to Floyd for doing this talk. Really appreciate it. Thanks to Ryan for running the stream. We do have one more question from Han. Can you talk a little bit about the difference between integration testing and end-to-end testing?
Sure. Um, so this one's fun because integration testing is one of those things that people will argue about the definition of it. So what I'll do is I'll tell you what I mean when I say integration testing, and that way you at least know what I'm talking about. So unit testing is going to be testing small little teeny tiny chunks of code. End-to-end testing is where you actually want to run the entire app with a real database with real everything and instrument it in an automated way. So integration testing is kind of the halfway point between the two. And generally, the way I write what I would call integration tests is I would take some chunk of the system. So, for instance, if we're talking about the back end, I would probably fake out the database so I don't necessarily have to have a database running. And then what I can do is I can instrument the back end using HTTP. So I can write using like a HTTP client. I can write tests and say, okay, I'm going to poke and prod the back end in a particular way, and I can make sure that the back end responds appropriately. Now, I can also do the same thing for the UI. So just like you should have unit tests for your C# code for the back end, you should also probably have unit tests for your JavaScript or TypeScript code that you have on the UI. But those unit tests aren't actually testing the UI completely totally put together. So if you think about the UI, it's kind of like a little application unto itself. And so you can write integration tests where you would build the entire UI in using like a headless browser or something like that, and then you just mock out the HTTP communication. So you can test the entire UI as it's all put together without needing to have a backend to talk to. And so when I say integration test, that's generally what I mean.
Okay, thank you. We haven't gotten any more questions since that one, so I think we're going to say goodbye to the stream here in a second. I posted a link to this call in Slack and on Twitch, so feel free to join us and join us in Slack if you haven't already. Floyd invited people to come on and ask questions there, and then find us again next month for Lightning Talks on the 2nd. So, okay, another question from Han. In a fast moving environment, a lot of times requirements can change, which change the tests. So, how does that affect writing tests?
That's a great question. So, if you remember, one of the things that we talked about is test fragility, right? So, tests at the bottom of the test pyramid should be less fragile, and tests near the top of the test pyramid are going to likely be more fragile. So, in a fast-moving environment where requirements are changing, you should be able to rely on those lower level tests down near the bottom of the pyramid to make sure that they're preserving quality. I will also say that you've got to be careful about your tests being coupled to your production code. Um, I see a lot of teams struggle with this where, well, if the code changes, that means we got to change the tests too. And if that's the case, then you've got to re-examine how you're writing your code, and you've got to re-examine how you're writing your tests, because the point is that the code is supposed to be the insurance policy that the tests are supposed to be the insurance policy that your code is doing the right thing. And that insurance policy doesn't help you if it's not helping you do that over time. So if you find yourself in a position where every time you change the code, you have to change the tests, otherwise the tests break, that means you've got too much coupling. And in an environment where requirements are changing, if that's happening frequently, a couple of things could be happening. One, you could have that coupling. Two, if the requirements are changing drastically, sometimes that's just the thing that you've got to wade through. I will also say, and I did sort of caveat earlier, we're not going to get into the requirements gathering thing. If you've got schizophrenic product vision, it's really, really hard to do this well, because it means every time you try to build abstractions into your code, the new requirement comes in and demolishes it, right? So the best thing you can do, because you can probably assume that most of the requirements that are coming in are going to make sense for the most part. The best thing you can do is be really, really careful not to create coupling between your code and your tests. Do not overinvest in software architecture. Remember YAGNI, YAGNI. You ain't going to need it. Don't build more than you need to, because if you overbuild in architecture and the guesses that you make, the assumptions, oh, we're eventually going to need this. A lot of times, product managers are really good at shooting down those assumptions. There's an article by David Heinemeier Hansen, who is one of the inventors of Ruby on Rails. The article is called "Winning is the Worst Thing That Can Happen in Vegas." It's a great article that talks about this dynamic where if you overbuild framework, it's this bet that you're making that I'm guessing at tomorrow's requirements, so I'm going to build it today. And if you do this, what winds up happening is you almost always lose, because you've got a big pile of code that you don't really need.
Yeah, again, great answer to a great question. I'm going to give it just a few more seconds for anyone to type up one last question. But again, feel free to join us on this call here in a second, or actually, you could just go ahead and join now. So I think we're going to be saying goodbye to the stream uh, pretty soon. Patrick says, I attended a great seminar where the presenter mentioned that if one has to redo something, the chance of making a profit goes to zero. An interesting point from Patrick there.
Can you repeat that?
Yes, I didn't do a good job of reading it. I attended a great seminar where the presenter mentioned that if one has to redo something, i.e., software, app, the chance of making a profit goes to zero. Would you agree with that, or do you have anything you want to say about
Um,
that?
I'm not sure I understand the context of it, but I think if I'm understanding it correctly, if you ship something broken and then have to redo it, it's going to cost a lot of money.
Mhm.
Um, you've got to be cautious with that. So One of the things that was really eye-opening for me, digging into that book, Accelerate, is that the highest performing organizations in software development and delivery have a change failure rate from 0 to 15%, which means they could be breaking stuff as often as 15% of the time. So 15% of their deployments that they do on demand every day, multiple times a day, is breaking stuff. Um, in a healthy environment, that's okay because the cost of that breakage is low. So what you want to do is you want to arrange your quality strategy so that yes, you want to prevent breakage, but also you want to make sure that if breakage does slip through, it doesn't cost that much time or effort or money to fix it. Um, that's better because if you're in a situation where it's all or nothing, either everything works or angry customers, buildings on fire, everybody's going to lose their jobs. This all or nothing scenario is misery. Um, and you don't want it. You want to try to create an environment where fixing things is easy and you've got a lot of computerized tools that help you make sure that when you fix it, it stays fixed.